Okay, so multiplexer. Okay, so multiplexer is also called data selector. Data selector. Okay. Data selector. Okay. So how can we define a multiplexer? So basically multiplexer or data selector. Okay, data selector is a logic circuit. Is a logic circuit.
तो ऊपर वाला नहीं दिख रहा है सर.
अच्छा. Okay. So it's a logic circuit that accepts several inputs. That accepts several inputs, but only one of them. Only one of them. Okay. Okay. One of them get through. Okay. Only one of them at a time get through at the output of multiplexer, or the output of multiplexer. What does mean? So basically multiplexer क्या है? Multiplexer है आपका data selector. Okay. So if you are giving n inputs, आपके पास n input दे रहे हैं, तो n inputs पे at a time आपको output में only one input will land. Okay. For example, what do you mean that? So shall I erase this one? Okay. So
Yes, sir.
So multiplexer, for example, I have a n-bit multiplexer. Okay. So you have a n-bit multiplexer. So you will be having n lines here. Okay. N lines. Okay. So for n-bit multiplexer, and this n lines also called select lines or n select lines. Okay. N-bit multiplexer. N-bit multiplexer. Okay. And here you have outputs. Here you have so many inputs. Okay. Say if there is an n select line, okay, it can handle 2 power n inputs. 2 power n inputs. So you will be having 2 power n inputs. Okay, that inputs are represented by I0, I1, I2, I3, I4, so on. Okay, IN. Okay. So sometimes instead of I0, they like 0, 1, 2, 3, 4 also. So there will be 2 power n inputs. Okay, but at a time, okay, depending on the select lines. Okay, select lines will be your A, B, C, D, so on. Okay, so, or sometimes we write as a S2, S3, S1, S0. Okay, instead of A, B, C, D. So these are basically your select lines. Okay, so A will be your most MSB. Okay, and that is here, for example, 4 select lines are there. So your A will be MSB and D will be your LSB. Okay, similarly, if you have S2, S3, S1, S0, S2 will be MSB, S0 will be your LSB. Okay, so this is your output Y. Okay, so this type of multiplexer is called basically 2 into n multiplexer. 2 into n 1 multiplexer. Okay, 2 into 1 multiplexer, or like for example, it will be like if it is a 4 select lines, okay, or 4-bit multiplexer, then we call it 16 into 1 multiplexer. Okay, or we call it 8 into 1 multiplexer.
So here line means input.
Multiplexer. Okay, So what is the mean of 16 into multiplexer? That means if you have a 4 select lines, okay, 4-bit multiplexer ko, the 4-bit multiplexer is called your 16 to 1, okay. If you have 4 select lines, okay, if you have a 3 select lines, okay, if you have a 2 select lines, if you have a 1 select line, and it is called your 2 into 1 multiplexer. 2 multiplexer, okay. So suppose you have a 1 select line and 2 inputs. So at a time, okay, only 1 input will land to the output depending on the condition of your select line, whether the select line is 0 or 1, okay. Similarly, if you have 2 select lines, okay, so you can handle 4 inputs, okay. So out of 4 input, only 1 will land at a time, okay. So sometimes instead of drawing this rectangle, instead of rectangular shape, we draw multiplexer like this, okay, like this. This type of shape, okay. So what does mean? All the inputs, okay, coming to outputs, all the inputs. So this is your 2 into n mux, okay. Here you have select lines. Sometimes we can mention select lines here also. So these are basically your inputs, okay. Now it's the inputs. Now input value can be anything. So there are totally n inputs, okay, and you have one output at a time, okay. So this is basically logic data set logic circuit, okay, which allows one input at a time to the output, okay. Now this multiplexer is the main use, is application is a use as a function generator. You can generate any logic function, like multiplexer can implement any logic function, okay. So that's why we call it as a like a universal gate, okay. Like with AND gate we can do any implement any function, okay. OR gate we can implement any logic function. Similarly with multiplexer you can implement any function, okay. You can even implement any type of gates, okay. So you can call it like it is a universal gate, okay. It acts as a universal gate, okay. Now first of all we'll see the simplest, that 2 into 1 multiplexer. What is 2 into 1 multiplexer? Okay, shall I read this one? So what do you mean by 2 into 1 multiplexer? 2 into 1, okay, multiplexer also written as a mu x, okay. So in 2 into 1 multiplexer, okay, what we having, you will be having one select line, say I call it S0, and you will be having 2 inputs, okay. I call them I0, I1. You can call it 0, 1 also, okay, and you will be having one output, okay. Now see how it works. This is my, okay, I0, I1 is coming, okay. So or you can write I0 here, say this is I0 and say this is I1, okay. So I have a one select lines, one variable S0. It can have value 0 or 1, okay. Then I have output, okay. I have this inputs say I have I0 and I1, okay, and the output Y can be written, this is a S0, so I can write S bar I0. This is the 1, so I can write S I1, okay. So output of this multiplexer will be basically S bar I0 plus S I1, okay. This is the output of this function. Now depending on the value of this one, if S0 is S0, okay, S0, if S0 is 0, okay, S0 0, this term become 1, this becomes 0, so you got only, So y is what? Y is equals to I naught. If S0 is 1, then y is equals to I1. Okay. So depending, though this is select line. Okay. You can go a bit or select line. But this the value of this one decide what you will get output. Okay. If you put this one 0, so then this will come in the picture. Okay. This will come at the output. Okay. If you put S2 to 1, then this will I1 will come, okay, to the land to the output. Okay, so this is a basically simplest circuit. Okay, and this is your output. So basically it's a combination of and or gates. Okay, so if I want to make say logic circuit for 2 into 1 multiplexer, so I need 2 AND gates. Okay, okay, and we'll be having one select line S. Okay, so here I want S0. So I want this should go here. So I want here, I want S0 here, S0 bar here. Okay, so say this is my S0 line. Here I want S0 I1, so this is say S0. So S0 is coming from here, and then you want again I1 I2. Okay, so say this is my I0, and here, okay, here I'm giving you I1. So this, and you have to make AND of this one or of this one. Okay, so this output will come here. So this output is your basically S0 I0, and this is your S0 I1. Okay, and you're getting Y. Okay, and Y is what? OR of this one, S0 I0 plus S0 I1. Okay, so this is basically simplest logic circuit of 2 into 1 multiplexer. Now similarly, let me draw now into 4 into 1 multiplexer. Okay, so you can instead of S0 you can take some A, B, C, D also. Yeah, now put adding 4 into 1 multiplexer. Okay, so 4 into 1 multiplexer will be having four inputs from I0 to I3 or 0 to 3, I0, I1, I2, I3, and select line you can choose A, B or S0, whatever you want. Okay, say A, B or S0, S1 or S0, S1, that is your choice, you can choose anything. Okay, and now I want to write the truth table. Okay, so if it's a 2-bit multiplexer, okay, 2 select line means 2-bit multiplexer, 2-bit multiplexer. Okay, so 2-bit multiplexer. So if I want to make this one, say so I have 2 variables this time. I have A, I have B. Okay, and then I have inputs. Okay, that could be right by IN. Okay, and then I have total Y. Okay, Y will be sum of all the things. Okay, not exactly Y. Okay, so this will be your what? This will be your 0 0 1 1 0 1 0 1. Now depending on the combination, okay, out of this 4, 1 will land at the output. Okay, so you have output I0, I1, I2, I3. Okay, so let me write now output Y. So output Y will be what? You can write the term 0 0. So A bar, B bar, I0. Okay, A bar, B, I1, A, B bar, I2, and if you have a B, I3. Okay, so you can see for the table, depending on the value of, if you're putting 0 0, okay, all other time will become 0. Only you will be I0 will be landing at the output. Okay, Similarly, if you put this 0 1, only I1 will be landing to the output, other sums will become 0. Okay, so depending on the select line, this is the way it is choosing, okay, which input should come to the output. Now this is a 4 into multiplexer. So by seeing this way, you can also make the tape logic circuit. Yes.
Sir, we are getting output same as input, no, sir.
Yes.
What is the use by
No,
this multiplex?
we are not getting output as like input. Input is I0, I1, I2, I3. Okay. Now this is using communication. I don't want to allow simultaneously all the input should come here. So I will choose depending on the AB. At a time, only one input will land. That's the definition of multiplexer, na? Out of it is a data selector. Multiplexer is basically what? Data selector. So if you are giving multiple inputs, okay, out of the it will choose at a time. It will choose only one input.
At the same time, we are giving, but getting one.
One we are getting one. We are giving several, but which will come to here, that will be decided by the value of the select lines. Okay,
Okay, sir.
so it will this is basically the data selector. Okay, that's why written here. This is basically your data selector. Okay, now you can make the logic circuit for 4 into 1 mux. Okay, so you want A,
तो
B,
इसमें y की वैल्यू कैसे निकालेंगे हम?
Y आउटपुट ना, ये वाला इज आउटपुट.
हाँ
ओके,
जी.
वो मैंने जैसे पहले लिखा था ना, टर्म्स लिख दो ना. ये क्या है, दिस इज 0 0, so this is A bar, B bar, इसको इससे मल्टीप्लाई कर दो, I0. Y will be basically sum of all these 4 terms is 0, so you put A bar, B को put 1, I1, and this is A, this is a B bar, I2, this is a 1 1, A B, I3, और जो Y जो sum of इस सबका है, sum है. ओके, इन 4 terms का.
Okay.
अब इसमें you put the values, you put this combination. Okay, if A is equal to 0, if A is equal to 0, B is equals to 0, then you get Y equals to what? I naught.
Yes, sir.
So like that, you can keep on putting the values and you will get the different data selector at a time. Okay, now what we should do, make this 4 into 1 multiplexer. So now we need instead of S0 S1, we need 2 variables. Okay, I need 2 variables, 4 AND gates. Okay, I need 4 AND gates now. So how should I make that different? Okay, let me make 4 AND gates. Okay, okay, and we are giving here the inputs. Say I0. What are the inputs? What are the inputs? Okay, Y is what? Y is your A bar, B bar, I naught. Okay, A bar, B, I1 plus
A,
B
A,
bar,
I2,
I2, and AB,
I3.
I3. Okay, so you have to give here I naught, you have to give I1 here you have to give I2, and here you go to I3. Okay, and then you have to give AB also, A bar, B bar. Okay, so let me select AB. So this is my, say, A line. See, this is my B line. Okay, so here you want A bar, so A bar, B bar. Okay, or what should I do? I should, let me draw here, somewhere here. Okay, let me draw somewhere here, A and B. So this is A, this is B. Okay, you want A bar, so A bar is coming here. Okay, this is the B line. Okay, you want B bar, and B bar is coming here. Okay, so here you are getting I naught, A bar, B bar. Okay, then here you want I1, A bar, A bar. You want A bar will come here, and you want B, so B will come here. So this will you A bar, B, I1. I1, A bar, B. Okay, here you want A, and B bar. So B bar is this one. Okay, you can take directly from here also, no issue. This is you have B bar already we are done, so you can put B bar here. Okay, this is your B bar. Just you to bring that things here. Okay, and this is your A. So this is basically A, and this is your B bar, and I2. So this will be your I1 A B bar. Okay, and then you have a I3. So I3 you need AB. Okay, so you need A. This is A, and say this is B. Okay, so is the, if you want to choose, you can make it down. Okay, because I'm putting in order. So if I want to put A, so this is my A, and this is my B bar. And the last will be your what? Last will be your I3 AB. Okay, now we will to make or out of this one. So this will be your or. Okay, you please you make nicely. My drawing is not good. Okay, so this is your output Y. So this is 4x1 multiplexer. यहाँ तक कोई डाउट है क्या? Okay. So Y is a combination of this one. Y is what? I naught A bar. I'm writing third time. Okay. I1 A B, then I2 A B bar plus I3 A B. Okay. Now let us see some problems. So one problem came in gate. Just
सर जो आपने नोट गेट का सिंबल लगाया उसके आगे नोट नहीं लगाएंगे आगे?
नॉट गेट का हाँ नॉट लगाना, सिंबल लगाना है. Okay, that you correct, please. Thank you. नॉट का सिंबल लगाना है. Okay. So this question came in gate. Okay, they're saying consider a 2-bit multiplexer. 2-bit means they are given input C and D. Okay, and they have the 2-bit, so they have total 4 inputs. Okay, connected to say A0, A1, 0, 1 to 3 inputs. They're connected to A1, A2, A3, and you're getting output Y. Okay, so they're saying the output is basically C XOR D. Okay, so it is given. Okay, we say the output is C XOR D. Okay, so the output is C XOR D, that is C D bar plus C bar D. Okay, then what is the value of, find the value, what are the values? What are the values of A0, A1, A2, and A3? Okay, so this is a 2x4 multiplexer. So you know what is the output. Output is basically what? Output will be what? C bar D bar, C bar D bar I0, then C bar D I1, then C bar I1 means this is 0, 1, 2, 3. Here instead of I0 is 0 is done. Okay, that we have to replace the values. Okay, and then you have C D bar I2, then C D I3. Okay, now C bar D bar, instead of I0 you have A0, C bar D you have a A1. Okay, and then you have a C D bar A2, and C D bar you have A3. Okay, so this is your output of multiplexer, and question, the output is given this one. You can compare this one and tell me what is the value of A0, A1, A0, A1, A2, A3. Tell me what is the values.
Sir, A1, A2, 1 and A0, A3, 0.
So one.
A1, A2 is 1 and A0 A30.
So here C bar D bar term is not there. C bar D bar term is, it means A0 is 0, isn't it? Then you have a C D bar term. C D bar. C D bar term. A2 is 1. Okay, A1. Similarly, you have C1 D bar. So A1 is also 1. A2 is also 1. A3 is AB in a CD term. CD term is not there. So this will be 0. Okay, this is the answer. Now, if you're confusion, please ask. Okay, clear?
Yes, sir.
Okay. Let me give some more problems. So you have been given a multiplexer MUX, okay, and you are giving W and inversion of W, okay. Obviously, your two inputs. So you have, they were given you S1, and the output of this here there is X, okay, and X is going again to some another multiplexer, okay, and complement of this going here. So this is also data, two data, say this is data 1, data 2, data 1, 0, 1, okay, or I0, I1, whatever what you can write, okay, and this is going to S2 here, okay, and you're getting function F. So find F, find F, find the value of F. So you have, okay, so this output is what? This output is basically S1 bar W
W bar.
plus S1 W bar, sorry, S1 bar and W bar, and then S1
Sir, S1 bar ఉంటుందా?
B, S1 bar, okay, so sorry, S1 bar, say I naught, okay, if you confusion, and then you have S1, you have I1, okay, so S1 bar is S1 bar, I naught is your W, okay, S1 is your S1, and I1 is your, this is W bar, okay, so this is your W bar, this is the notation or input, okay, so this is your X, okay, so but basically this is what it is, basically SW S1 XOR W, okay, and this is going here, so this is basically X bar, okay, and this is X going here, so again you are S2 here, so you got F will be what? F will be your S2 bar I naught plus S2 I1, okay, now S2 bar little like this, I0 is your X, okay, and then here your X bar, your S2 is I1 is your X bar, so put X bar, okay, put the value of, and this is what, again this is S2 XOR X, okay, and X is your what? S2 XOR S1 XOR W, okay. So tell me whether this will be equal to S1 XOR S2 XOR W. It is clear. It is. Can we write like this? Variable. Okay. So variable as polo commutator relation. Variables we can change. This Boolean algebra, Boolean variables. Okay. That is commutative. So this is equals. Okay. So S1 plus S2 S1. Okay, you can write like this. So we'll do some couple of more problems. Is clear? Is your doubt is में? If you doubt, please ask. These very simple questions. Okay. So let me do now second problem. You have been given a 4 into 1 mux, 4 into 1 mux. Okay. Then you have a I0, I1, I2, I3. You have been given data here. Okay. And here you have one more, this one here, and this is connected to ground. Ground means 0. Okay. So when 0 is going here, you're getting 1 here, you're getting 0 here. Okay. So 1 is going to I1. Okay. And 1 is going to I2. And 0 is going to I3. And they're asking what is the function f, and they are given you select variable as a PQ. Solve and tell me what is the answer.
So we have to find PQ.
अब PQ कभी निकालते हैं क्या? F निकालते हैं. PQ तो वेरिएबल्स है ना.
सर P XOR Q.
P XOR Q आएगा.
Yes
Okay.
sir.
So F क्या है आपका? F is basically what? P bar Q bar I naught, P bar Q I1. Okay. P Q bar I2, P Q I3. Okay. Now I naught is what? I naught is 0. So this term becomes 0. I1 is 1. This term becomes P bar Q. I2 is 1. This becomes P Q bar. I3 is again 0. So this term becomes 0. So this is simply P XOR Q. Okay. So this type of simple questions will come in exam. Okay. Now we'll see the applications. Okay. Like here I'm generating some function. I'm generating XOR gate out of this one. 4 into 1 multiplexer. Okay. So that means as I told you in the beginning, it is a data selector, but plus it is a function generate. You can generate any function generate using these multiplexers. Okay. So let me give you one example. So now put the heading function generators using multiplexer.
अरे इसमें हमने ये वैल्यू चेंज करते हैं यहाँ से 0 और 1.
चेंज, हाँ नहीं, अगर वो चेंज क्या करते हैं, जो इनपुट दे रहा है वो लगा रहे हैं, इनका इन्वर्टर लगा रहा है, तो इन्वर्टर लगे हुए थे ना वहाँ पे. तो
सर
हाँ जी सर.
सर हमने तो ये स्टेटमेंट मतलब हम ये कह रहे थे कि मल्टीप्लेक्सर जो है वो सेलेक्ट जो
हाँ.
सेलेक्टिंग लाइंस है उनके अकॉर्डिंग वी विल
हाँ.
गेट द आउटपुट
हाँ हाँ.
बट लाइक वी इन द प्रॉब्लम्स वी आर गेटिंग द आउटपुट
प्रॉब्लम
अकॉर्डिंग टू द इनपुट.
वो प्रिंसिपल तो वही है ना. If you give PQ values, you get output according to you get outputs. Okay. Now you got simplified function. Okay. Like you got F equals to P XOR Q. Now you give value P or Q value, either you get 1 or 0. Okay. Okay. So output also you're giving 0 or 1. Na? Input also you're giving 0 1. 0 1, you are giving what 0 1 1 0. So you give the PK value, you get that input and that input at the output. Okay. तो ये तो प्रॉब्लम्स है, एग्जाम में प्रॉब्लम कैसे बनाएंगे? एप्लीकेशन तो वही है ना, कंसेप्ट तो वही है ना. ओके. नाउ फंक्शन जनरेटर. बहुत आसान है, function generator. Okay, so for example, if I want to make a, let me give one problem. Okay, I want a multiplexer to implement. Okay, implement a function f equals to, say, a XOR b, a XOR b XOR c. This function, okay, implement this function using multiplexer. Okay, I want to implement, okay, this function using multiplexer. So how can I approach? The approach is simple. You have to see how many variables are there. Okay, you have 3 variables. That means this is 3-bit multiplexer. That means these are select lines. Okay, so first of all, we have to see now what are the inputs. Okay, we know the select lines. Now we have to decide what are the so 3 variables can have 8 inputs. Okay, and what are the inputs we have to decide. Okay, output already be given. Let's just say question kya tha वैसे ही. Now you have to find what are the inputs. I0 to I7. Okay, 3 variable function can have 8 inputs. So we have to find what are the inputs basically. So now you have function. Okay, so you have multiplexer. Okay, and f is given to us, a XOR b XOR c. Okay, and you have to find now 0 1 2 3 4 5 6 7. Okay, that is basically you have to find the value of I naught. Okay, this is I naught, I1, I2, I3, I4, I5, I6, I7. You have to find the values here. These values you have to find out basically. Okay, so if you implement any, then only so you can find what are the values of this. Okay, now how should I approach this problem? Okay, so let me make a truth table now. Truth table of A, B, C. Okay, and then function A XOR B XOR C. Okay, so this is 0 0 0 0 1 1 1 1. Okay, 0 0 1 1 0 0 1 1. Then I have 0 1 0 1 0 1 0 1. So now it's the XOR gate. You know, XOR gate will give you output 1 only when there is an odd number of 1. So this will be 1. So this is 1. This is 1. This is 0. This is 1. This is 0. 0. 1. Okay. Isn't it? Okay. So now basically what become 0 1 0 0 0 1. Okay. So this is basically what? This is your M0. Okay, this is basically your M1, this is M2, M3, M4, M5, M6, and M7. Okay, so basically your function f equals to A XOR B XOR C is basically equals to summation of what? Summation of M1. Okay, M1, then you have M2, and then you have M4
M7.
and M7. Okay, so basically this is a function. Okay, now these functions are present, and here these are the variables ABC, A, B, C. Okay, now which are the term present? Okay, which are the term present? Now if I write inputs I, okay, there will be I0, I1, I2, I3, I4, I5, I6, I7. Okay, so in front of I0 is 0. Okay, so you write you have to, your input will be here 0. Okay, so you have total 2 inputs, 0 and 1. Okay, so you have a 0. Okay, and you have an input 1. Okay, now you have to choose where 0 will come and where 1 will come. Okay, say this is a 0 line, say this is a 1 line. Okay, now you are where I0 is your 0. Okay, so connect with 0. So this is connect with 0. Okay, I1 is 1, So connect this. This is with 1. Okay. Then I2 is 1. Okay. So basically what you do, you connect this one I2, then I2 I4, then you have I4 connect, and then you have what, I7. So I7. So these all are ones. These all are ones. Okay. Or you can put like this also. These are ones. Okay. Now 0. The remaining also 0. So put 0 here. So this is 0. Okay. Then I1, I2. This is your 0. Okay. This is your 0, and this is your 0. Okay. So we are giving like this inputs to this one. So when we give, so basically we want to find I0, I1, I2 values. So these values we have done. Now if you open this one, we will get this function. Okay. If you want, you can try. Okay. If you want to write the output, you can write the output. Kaise? Now suppose you have a 3 variable function. Okay. So the output of this one, okay, will have 8 terms. 8 terms means how? This one, A bar, B, C bar, I naught, then 0 0 0 0 1, that is A bar, B bar, C, I1. Then you will be having third 0 1 0 0 0 1 0, this will be I2. Okay, then 0 1 1 0 1 1, this will be multiplied by I3. Then I4 1 0 0 A, B bar, C bar. Okay, and then you have fifth I5 1 0 1 A, B 1 0 1 A, B bar, C. Okay, I6 is nothing 1 1 0. So 1 A, B, C bar, and I7 is your 1 1 1. So I7 you have A, B, C. Okay, now you can put the values. I0 value is 0, so this term becomes 0. So you have only A, B, C. I1 is 1, I2 is 1. So you have A bar, B, C bar. Okay, and then you have A, B, C. Okay, I3 is 0. So 0, I4 is 1. So you have A, B bar, C bar, and then fifth is also 1. Fifth is 1, na? Fifth is 1. What is value of fifth?
Fifth is 0, sir.
Fifth is 0.
Only 7, last 7.
Last 7.
Seventh one.
A, B, C. Okay. So this is function. Now, if you want, you can solve this function, or if you remember mg, what is the value? This is the m1, m2, and this m7. This is the A XOR B, A XOR B plus C. Okay. Or you can make K map, and you can solve this one. Okay. So you will see that will be your A XOR B C gate. Okay. Or you can take simplify here, take something common, and then you find. So say A XOR, what should I take common? If I take this C common, C common here, so A bar, B bar, then A, B, C. Okay, and here what should I take common? Here I should take C bar common. So A bar, B plus A, B bar, that is just C bar. Okay, so this becomes your A XOR B C plus this becomes your A XOR B C bar. So basically this is what your A XOR B XOR C. Okay, so no need to check. Okay, just you have to put the input values. So it is implement this function, okay, using this one. So you write a truth table, okay, and which are the min terms are present, correspondingly you put 1, other you put 0. So automatically this function will be equal to this one. Just for showing, I have shown this one, that it is they both are same. Now this multiplexer will give you the output this. Clear? And out? Okay, so if it is clear, let me take 5-minute break, and then we'll come back again. Okay.